So, welcome everyone to the class of quantitative methods of management. So, we have discussed about median in the last class. Now, continuing on the same family of the partial value, now guys will start about discussing quartiles in this class. Imagine that you are analyzing customer satisfaction scores from surveys where the score range widely and you want to identify how much variation exists around the middle half of the data so that you can understand consistency. So for example, like you can say that most customer moderately are satisfied or they are extreme pulling out the averages. So how can you calculate this variability using quartiles? Why would this measure such as quartile deviation is important in making data driven decision? So we'll discuss about that in this present class. So at the end of this topic you will be able to describe the calculation of quartile deviation for raw data, describe the calculation of quartile deviation on discrete series, explain the numericals on continuous series based on quartile calculation.
So first, introducing the term quartile. So quartiles, I believe you have understood median. Okay, so the quartile is belonging to the same family of median, although the median talks about the 50% or central part of the data, where quartile is all about like if you explore the data from origin to the 50%, then the half of that where would you find 25% of data, or the latter half from median till the end, the other half of the data where you talk about 75% of data is basically represented by quartiles. So in quartiles, we'll focus on 25% and 75% of the data, where the idea is to determine the middlemost value between the initial data to the median, which we call as lower quartile or Q1, and similarly between median to the total data, where the middlemost value is called as upper quartile. So talking about quartiles, okay, so here like you can imagine that you have a set of data which you cut into three parts. Okay, so the middlemost part is your median, and the first half of the part, which represent 25% data, would be a lower quartile, while the next half would be your upper quartile. Okay, so this is your median, the 50%. The 25% of data is your lower quartile, and 75% of data would be your upper quartile. Now talking about the formula for the quartile deviation. So like median in the calculation of quartile deviation, we need to arrange the data in ascending order, and then we find Q1 and Q3, where the formula of Q1 is n plus 1 by fourth observation, while Q3 formula is 3 into n plus 1 by fourth observation. And the quartile deviation is nothing but it is the arithmetic difference of Q3 and Q1, and that difference we divided by 2, and that will called as a quartile division. Okay, now consider a problem here. Like if I give you certain set of data like 25, 18, 38, 15, 5, 10, 35, 40, and 55, 45. For this, if I'm asking you, tell me the quartiles for this calculation. So first of all, you have to arrange the data in ascending order. So when we arrange this data in ascending order, so we got 5, 8, 10, 15, 18, 25, 30, 35, 40, 45. Okay, so once we got the data arranged in ascending order, then we can apply the formula of Q1 and Q3. And since we know that the number of terms here is 10, so quartile 1 would be 10 plus 1, which is 11. 11 by fourth observation. That is 2.75th observation. Now the first observation is 5, the second observation is 8, and the third observation is 10. So we want here 2.75th observation. That is my quartile 1. And for that, to find the 2.75th observation, I have to apply the interpolation formula, where 2.75th observation is nothing but second observation plus 0.75, I can write as 3 by 4, into third observation minus second observation. So where your second observation is 8 and your third observation is 10. So 8 plus 3 by 4 in bracket 10 minus 8. 10 minus 8 is 2. 2 into 3 by 4 is 3 by 2. 3 by 2 is 1.5. 1.5 plus 8 is 9.5. So your quartile 1 is 9.5. Okay, and similarly, going further, if I have to calculate the upper quartile, for the upper quartile, same thing, I'll apply the formula 3 into n plus 1 by fourth observation. So n plus 1 by fourth observation, we already got the value called 2.75. 2.75, when I'll multiply with 3, what I'll get 8.2 fifth observation. So 8.2 fifth observation is nothing but eighth observation plus 0.25 into ninth observation minus eighth observation. So here the eighth observation, if you count, so 5 is first observation, 8 is second, and 10 is third, 15 is fourth, 18 is fifth, 25 is sixth, 30 is seventh, and 35th is 35 is eighth observation. So eighth observation, I'll take 35 plus 1 by 4, and then ninth observation is 40 minus eighth observation. 40 minus 35. So 40 minus 35 is 5. 5 by 4, if I do, I get 1.25. And that 1.25, if I add with 35, I'll get the quartile 3 as 36.25. So I got quartile 1, I got quartile 3. Based on the formula of quartile deviation, I can find Q3 minus Q1 by 2. Q3 is 36.25. Q1 is 9.5. And then if I apply that formula, I'll get the quartile deviation is 13.37. Okay, so imagine if I give you discrete series, and for that, if I'm asking you to find the quartiles, okay, so what we need to do first, we from the frequencies given, we have to find the cumulative frequency, and then we have to find n plus 1 by fourth observation to find the lower quartile, and that will multiply with 3 to find the upper quartile, and then we need to see in the frequency cumulative frequency table, the value which is next greater than n plus 1, because for the Q1 we have to find n plus 1 by 4. For Q3 we have to find 3 into n plus 1 by 4. So imagine that if I'm looking to calculate Q1, so first I have to find n plus 1 by 4, and then what we have to do, once we found the n plus 1 by 4th, then we have to see the cumulative frequency table. We need to see the next value which is greater than n plus 1 by 4. Okay, and the next value what is greater than n plus 1 by 4th, the corresponding x value for that is your the respective quartiles. Okay, so similarly for Q3, I'll find 3 into n plus 1 by 4. And then I'll see in cumulative frequency table the value which is next greater than 3 into n plus 1 by 4. And then the corresponding value of x there is the Q3. Okay, imagine that this is the numerical what is given to you, where certain datas are given to you, and the frequency is given, which is talking about how many times that value is repeated, like this value 5, which is repeated 4 times, then you have value 8 repeated 3 times, then you have value 12 repeated 2 times, value 15 repeated 4 times, value 19 repeated 5 times, value 24 repeated 2 times, value 30 repeated 4 times. So the total, you can, if you count this sum, 4 plus 3, 7 plus 2, 9, 9 plus 4, 13, 13 plus 5, 18, 18 plus 2, 20, 20 plus 4, 24. The total 24 data is there. First, we have to find the cumulative frequency. So cumulative frequency of 4 would be 4 only. Cumulative frequency corresponding to 3 would be 4 plus 3, that would be 7. Then corresponding to x value 12 would be 4 plus 3 plus 2, means 7 plus 2, 9. And then simultaneously 9 plus 4, the cumulative frequency would be 13, then 13 plus 5, it would be 18, 18 plus 2, it would be 20, 20 plus 4, 24. So you got the cumulative frequency data here along with the x and frequency data. So once we got this for the lower quartile, we need to find n plus 1 by 4. So here the total sum of n or frequency is 24. So we'll apply the formula 24 plus 1 by 4. So you'll get 6 point something, right? 6.25 and all. So if then you have to see that value 6.25 in the cumulative frequency table, and you have to see the next value which is greater than 6.25. Okay, and that X value, which is 8, is your lower quartile, not median. So here we are talking about quartiles. So here, once you find the cumulative frequency, then n is 24. So 24 plus 1 would be 25. 25th, 25th by 4, 6.25. So the in the cumulative frequency table, the next value which is greater than uh, this value here, 6.25. So the next which is greater than 6.25 in the cumulative frequency table is 7. So the corresponding value of 7, 8 is the 8, that is your lower quartile. Similarly, for quartile 1, what we'll do, we'll need to look for the value 18.75. And by the cumulative frequency table, you can understand that the 18th value got ended at with the X value of 19. 18.75th observation means your upper quartile is 24, and your lower quartile here is 8. So then you can apply the formula. You'll apply the formula of Q3 minus Q1 by 2, and with that you will get the quartile deviation. So your Q3 is 24, your Q1 is 8, 24 minus 8 is 16, and 16 by 2 is 8. 8 is the quartile deviation. Okay, so you got the Q1 as 8, Q3 is 24. Okay, so uh, imagine if I give you continuous data, then how will you find the quartile deviation? For that, we need to find first the cumulative frequency. Okay, and then like what we have done in the previous question, we have to find the value of n by 4. So if you see in the frequency continuous frequency table, the next value which is greater than n by 4, the corresponding class interval is your quartile class. Okay, then for upper quartile, same thing we'll do. Only thing is that in the case of discrete data, you have single value of x, and when you have what you say class interval and frequency, so you have lower limit, upper limit, and all. So the x value would be lying between the lower limit and upper limit, and that what we have to figure out here. Okay, so you have to see in the cumulative frequency table the value just greater than 3 n by 4, and then the corresponding class interval is called third quartile class. And then we apply the formula to get the answer. Okay, so this is the formula of quartile 1 when we have a class intervals and frequencies, where L is the lower limit, N is the total sum of frequency, your M is the one cumulative frequency before the selected class interval, F is the frequency of the class interval, C is the height or the difference between the upper limit and lower limit of the class intervals. Clear. L is your lower limit of first quartile class. F is your frequency of the first quartile class. C is the width of the first quartile class. M1 is the one cumulative frequency, the selected class interval. One cumulative frequency. In the cumulative frequency table, you see the preceding value from the range what you selected, where you think that the cumulative frequency is hiding. So we before that I have shown you the formula of quartile 1. Same wise, we will find the value of quartile 3. And you don't have to remember anything. Just by observing, you'll understand the difference. The only difference is the n by 4 and 3 n by 4. N by 4 is for uh, the lower quartile, while 3 n by 4 is for upper quartile. Now, in this question, you can see the class intervals are given, and the class intervals are continuous in nature. You can see that. And the frequency is given as a number student, and you have a class interval from 0 to 10 to 90 to 100. And you can see the number students here. You can add the total number of students to find the total frequency. And for median, quartile, decile, percentile, we need to find the cumulative frequency here. Okay, so like cumulative frequency would be for 11, it would be 11. Then it would be 11 plus 18, 29, 29 plus 25. It would be 54, 54 plus 28, 82, 82 plus 30, 112, 112 plus 33, 145, 145 plus 222, 167, 167 plus 15, 182, 182 plus 12, 194, 194 plus 10, 204. Okay, so cumulative frequency we got, then n by 4, 204 by 4, you will get 51. Then in the cumulative frequency table, I need to see the next value bigger than 51. The value is 54 and the class interval for that is 20 to 30. So the L would be 20, frequency would be 25. And one cumulative frequency before 54 would be 29. So the here CF or the cumulative frequency would be 29. Okay, the L would be 20, frequency would be 25, class width would be 10. And similarly, when I do 3 into n by 4, I'll get the value 153. So 153, the next value would be the class interval 60 to 70. The frequency is 22. Okay, so this is the formula of quartile 1, L plus n by 4 minus lope or minus one cumulative frequency before the selected class interval. Like in this case, so like in this case, one cumulative frequency before the selected class interval for Q1 it would be 29, and for Q3 calculation it would be 145. So L we understand, what is H also we understand. Uh, we can understand M also. All the terms we can understand. So this is the formula of Q1. So L is 20, the N by 4 is 51. Okay, so is the one cumulative frequency. Before that, it is 29, and the frequency for the corresponding class interval was 25. So we can solve this question to find the value of Q1. And so, and the value what we get for Q1 is 28.8. Similarly, we like the same way, like the way we calculated Q1, we can find Q3. L we know the M value, we know the frequency value, we know the class width. So the L is 60 and N3 into N by 4 is 153, and and basically one cumulative frequency before that is 145. Okay, and the frequency for the corresponding class is 22, and the class width, when we measure the class width, that would be 10. Class width is 10 only. Okay, the class width would be 10 only. Fine. So we just apply the formula 60 plus 153 minus 145. What you will get is 8, right? 8 by 22, 8 by 22 into 10. So 80 by 22. So if you do 80 by 22, so you will get is 40 by 11. 40 by 11, if we talk about 40 by 11, is 37 by 11. 37 by 11 means 3.5454. Okay, so if we solve this, this would be 80. This would be 10. 80 by 22 means 40. 80 by 22. 80 by 22 means 40 by 11. 40 by 11 means 40 by 11 means 3 7 by 11. 3 7 by 11 means uh, 7 by 11 is 6363, like that. So here I'll get the value, and the corresponding value we are getting is 64.36.
So in this topic, we have learnt about quartiles. So when we talk about quartiles, quartiles divide the data sets into four equal parts, focusing on the lower and the upper quartiles. Okay, when we say lower quartile, it is Q1. When it is upper quartile, it is Q3. When we talk about quartiles, when we talk about calculation of quartiles, here we have discussed how we can calculate quartile for the raw data, for discrete series, for continuous series, each with specific steps and example. So guys, when it comes to quartile deviation, it measures the spread of the middle 50% of your data, which provides you insight into data variability. So when we talk about quartiles, quartiles are useful for analyzing data distribution and identifying trends within different data set segments. So I hope you have understood the concept of quartiles, what we have discussed in this class. So it was wonderful session discussing this concept of quartile theoretically and through practical examples. So it's time to wind up this session. I'll see you all in next class. Take care. Happy learning.